Good afternoon, everybody. My name's Tom. I'm from the Department of State Development, and I'm doing the decarbonisation information sessions in partnership with the BAE. As you would know, Darren Rowe is the president of ICOMIA, and ICOMIA has done a 550-page report on decarbonisation in the recreational maritime industry. And obviously, the Queensland Government is very, very keen to find out what the results were of that study. As you were aware, the Queensland Government is very heavily focused on decarbonisation. That does not only include maritime, but includes obviously land and air as well. There's a lot of money being pumped into that particular aspect of decarbonisation, whereas maritime is a big part of it. Today we're just really covering the recreational industry and small commercial. Now we've got our keynote speaker, which is Darren Rowe. He's the president of ICOMIA, and will give us a presentation of his 550-page report in about 25 minutes. And it's a very outstanding report, and it's very interesting, especially from a government perspective, because actually it did open my eyes quite radically yesterday, actually what actually are the key areas of focus in the recreational maritime industry, and it's definitely not what I thought it would be. So please welcome Darren Rowe.
Great. Thanks, Dr. Tom. Look, this afternoon, there's a fair bit of content to get through with this study, but what I'm going to do is just try and step you through it. Like Dr. Tom said, the reality is we've got a 558-page report prepared by some of the smartest engineers in the world, and my job is to try and distill it down to a language that we all understand and that we can actually start to make forward plans on how we actually address this important issue. So just to start off, to give you the background of what it's about, this has been a 2-year project that we've worked on at ICOMIA. We've engaged across all of our members, so we do have members that span across the globe. We do have access to all the major corporations that are members of our members. So the members of ICOMIA are effectively the lead trade associations, marine trade associations, in all of the major countries around the world. In fact, we represent 90% of the global turnover of the marine industry, which is forecast to have an economic impact of about 400 billion Australian dollars worldwide. So, our industry actually is significant on a global basis. So to actually undertake an exercise like this, to do it properly, the purpose of it was to actually fill an information void. So when you get to policymakers having to make decisions about how to actually do things like how do you set a strategy for decarbonisation, how does our industry respond, you need real information. So we decided the best way to do that was to go to the leading consultants in the world. So we went to Ricardo. Ricardo is a company with 3,000 employees, represented in 20 countries, and are recognised as the world leading experts in undertaking life cycle assessments. So they work in aviation, defence, finance, property, transport, all sorts of sectors. And so they've got the expertise and the data sets to enable them to do it. But the most important thing is that they're recognised and accepted. Their advice and reports are recognised and accepted by governments and key policymakers. So we had the report prepared by them. It cost hundreds of thousands of euros. This is an exercise that was very significant. But more importantly, we had it peer reviewed by 3 parties, 2 technical experts and a devil's advocate. And the devil's advocate's role was to go through the report and identify every argument that you could put up to actually take the report down. And so the idea was to create a robust set of data that our industry can rely on to actually move forward so that we've got a meaningful strategy. So that's the background. But the fundamental question is why? Why as an industry do we actually have to do anything about that? Why as trade associations do we actually need to take any steps into this space? And the key element is that 196 countries and other parties all got together in 2016 and all agreed that we're going to reduce carbon. We've got a peak in 2025. We're going to reduce carbon to 43% below 1990 levels by 2030. 4 weeks' time, it'll be 2024. 2030 is like next week in the terms of those sorts of outcomes. And surprise, surprise, we're nowhere near achieving it. So if you think about the consequences from a regulator or a policymaker's point of view, when they're looking at it and saying, we've made this commitment, we need to do it. And what it's about is they're saying if you get it to 43% down, then we'll reduce the increase in global temperature to 1.5%, which is seen as the threshold of acceptability. Beyond that, there's great uncertainty about what's happening. The current model indicates that it's more like 1.8%, which is a great concern. What it means for us in our industry is ultimately regulators and policymakers will start making fundamental decisions about how do we cut carbon. And the easiest way to cut carbon is to stop carbon creating activities. So we need to be in a position where we can produce information so that those decisions are not made in an information void. So that's the fundamental reason behind it, because one of the interesting things, of course, is that our industry contributes 0.1% of total carbon emissions globally. 0.1%. If we were carbon neutral tomorrow, it wouldn't even move the dial. You wouldn't even see it on the graph. But, and this is the thing, it's all about perception. And if you think a regulator sitting in a room or a policymaker sitting in a room that's charged with the responsibility to reduce carbon, and they think about our industry, what do they see? They see that. Because this is the way that we actually sell our industry. We have, most of the imagery we do is high-powered boats going fast. Everything's about movement, everything's about dynamics and all of those sorts of things. And so this is one of the challenges that we have in terms of how we actually address and how we communicate our industry. Because the fundamental premise is that this is actually what most people are doing. And I think that in its regard, and this is where it gets really important, part of what we do when we try and communicate what our industry is about, it's not about jumping on really big boats and going fast all the time. In terms of that perception. It's about actually, most people get on their boats, they go to a destination and they recreate in that location. They either fish, they go for a swim, they have a picnic, they do all of those sorts of elements. That's the way that most people boat. And what's important about that, and part of the studies we've done, which is outside today's topic, but it's orientated towards this single premise that boating enriches people's lives. The very act of being in, on or around water is good for human beings. And so from a policy point of view, you know, if there's this reaction to say, well, look, that's a discretional activity, we should limit its ongoing thing because, you know, it's creating carbon, it's doing all these sorts of things, the social consequences of actually doing that are significant. And this is part of the reason why that we have to fight so strongly. Firstly, to protect the industry that we all believe in, but at the same time, it's actually important. It's a highly engaged activity across our community, and it actually creates social good. And so this is part of the argument that goes beyond the technical aspects of this report as to why it's worth defending at the highest policy levels. So the study itself, 2 years in the making, we had the ability to be able to tap into the resources of our industry and the data sets across the world. But the most important thing was that we had access to Ricardo with their incredible data sets to actually undertake this particular study. So life cycle assessment. Just to be clear about what that means. So this is effectively, the terminology you'll hear is things like cradle to grave. So in other words, from the inception of the product, right from its source materials, right through to its end of life. The other term that we use is well to wake, and particularly in relation to energy sources and propulsion, because this study is about alternative propulsions. We're not getting into, we've used a standardised hull designs and various things that I'll explain, but we're not talking about trying to get into efficiencies of hulls or foiling or all those sorts of things. This is a study into alternative energy sources and alternative propulsions in terms of their carbon footprint. And what's important about the well to wake scenario is that we go right back to where the materials are mined, where the energy comes from, where it comes out of the ground, and all through its transportation and manufacturing processes, right through the life of its operations, right till it gets to the end of its life. And that's why the study is really important, because we've calculated, Ricardo's calculated in their study, the total amount of carbon that exists through that whole process, and then compared all of the alternatives. And that in itself is really powerful. So this is what we assessed. We looked at a range of different propulsion systems. We used a baseline of gasoline or diesel, petrol or diesel, and then we looked at sustainable drop-in fuels, we looked at hybrid electric, we looked at full electric, and we looked at hydrogen used in two ways, hydrogen in an internal combustion engine and hydrogen within a fuel cell. Now, there are plenty of other alternatives in terms of methanols and butanols and various other bits and pieces, but when we looked at the mainstream applications for this study, and this study is about recreational boats, so boats under 24 metres, in fact the largest boat in the study is 19 metres, these were seen to be the most viable alternatives. And in terms of the craft type and selection, which you can see there, the 9 different craft type, they're a reflection of what the majority of the boating industry has as existing stock and what it has as currently manufactured stock. It's the most representative set. And the reason that's important, and there's a point that I need to emphasise here, this study is about how we decarbonise the recreational marine industry, and that is, how do you decarbonise the vast majority of the recreational marine industry? It doesn't deal with every possible craft type, it doesn't deal with every possible scenario, it deals with how you actually take our industry and move it in the fastest way possible to a decarbonised position. So in the study itself, there were 45, obviously you've got 5 by 9, 45 full life cycle assessments that were able to be compared. And you could imagine each of those models, when you're looking at every single component and material that builds up a propulsion system, every possible way that the energy source gets to the particular craft, what the grid mix of the electricity is, what the transportation infrastructure is, based on the most comprehensive data sets, predominantly from North America and Europe, but also globalised, to actually create these models. And so here's some of the core data that were the underlying assumption sets. And the last 2 columns are the ones that I want you to actually have a look at, because this is the one that's particularly interesting. If you look at the engine hours per annum, these are the engine hours that come from the service records from all the major manufacturers, which are accepted by bodies like the EPA in America and various other bodies across Europe and otherwise as the reference data set for what engine hours are. And the most important part of that is most recreational boats have engine hour usage of less than 50 hours per year. And that's predominantly because, as against the picture of going fast and driving everywhere, the reality is most people get on their boat, go somewhere, and then sit there, and then come back again. And we all know how many times people generally use their boats a year. Now, this is a representation of the majority of the market. So it's a representation of single ownership, private ownership of craft. It's not about clubs or hire or syndicates or those sorts of things, which have much higher use case scenarios, because they're not the bulk of the market. This is a reflection of the bulk of the market. The other thing that's really important, particularly in sustainability, is that durability is actually a key component of sustainability. If you make durable products, then obviously there's a lot more value in the materials that are being used for a long period of time. And so the best example that you see around the community is fast fashion. You know, they make a T-shirt, you can wear it for about 3 weeks and then it's all out of shape and you have to throw it away, which is very bad from a sustainability point of view. We should be very proud of the fact that we make vessels that last for a very, very long time. But that comes with consequences. When you're doing life cycle assessments and you're looking at alternatives, the propulsion systems themselves have certain lifetimes that may be less than the life of the craft, and that starts to get built into the overall picture. So those sorts of inputs, and you can see the different power ranges and lengths and fuel sources and all those sorts of things, everything is benchmarked against what is available in the market today, fueled with fossil fuels. So in other words, what we're trying to do is do an absolute full LCA assessment compared to what the baseline is, which is that. So the challenge is, you can't do a complete apples for apples comparison. And I know this, I'm not going to try and explain this graph to you, this diagram in full detail, but I want to get a principle across to you. The reality is that if we use diesel in a comparison to a lithium-ion battery, the energy density of diesel is about 30 times more than a lithium-ion battery. So that means for the same energy transfer, you need obviously 30 times the volume if you want the same range and performance. However, An electric motor tends to be about 300% more efficient in taking stored energy in a battery and converting it into forward propulsion. So the equation's more like 10 or 11 times. But the reality is that you can't put 10 or 11 times the volume of fuel that you would store on a boat in batteries because it doesn't fit. Same with hydrogen. Even if you store hydrogen at 700 bar, it still doesn't have the energy density of alternative liquid fuels, whether they're sustainable fuels or fossil fuels. So as a consequence, you can't do a study to say, well, I'm just going to compare them on an equivalency basis because the craft A won't float, isn't practical, and all those sorts of things. So what the engineers did was that they then took a view and said, right, we're going to set a performance criteria that we can do on a proper comparative basis. So if you look at this craft here, this is the standard one using gasoline. It's got 14 hours of runtime, just as an example. What they ultimately included within the model was a craft that had 3 hours of runtime. And that 3 hours of runtime is what's built into the LCA models. So when we're doing the comparison, we're doing a comparison of the craft with batteries and various elements, or hydrogen and various elements that are built in, but with reduced performance. And depending on what the craft type is, that the range and performance of that craft is 10 to 20% of its alternative. But that's what we've compared. So it's important when the results come up that you actually understand that that's the criteria that's actually behind it. So the important thing, where does it get to? What was the results out of all of this work? And the non-shocking outcome from it, actually, I jumped ahead of myself. So the reality is that the process that we went through to actually evaluate this was that we had all of the options. We looked at the greenhouse gas, so the CO2 implications of each of the options. We also took into account the cost, because I think when we do look at the outcomes from it, even though we're focused on the carbon, the actual consumer cost and take-up was going to be an important part. The power systems implications, as I was talking about, as to what you could do. The infrastructure implications, so there was some important considerations about availability of infrastructure, change of infrastructure, and how you actually got power onto a marina to charge boats and various other bits and pieces. So that could be taken into account in terms of the overall model, and then ultimately to come up with a whole range of different criteria for suitability and ranking. But this was the key finding, and it's not a surprise. There is no one-size-fits-all, because within the industry itself, there is a diversity of use types, there is a diversity of craft, and there's a diversity of applications. And before I go into the fine details, I'll give you a good example. We had a presentation from GoBoat yesterday about their small electric craft. And this is a really interesting example, because what they've got is they've got a very small rated engine, and they've designed the batteries, which they're using gel batteries instead of lithium ion on their batteries, to suit the charge that would require the hires over the course of a day. So effectively, they've got about 8 hours range of those craft. They're utilised for non-licensed operators, and so they're running under 10 knots, so they're just running at a lower pace, and it enables them to be able to charge them overnight and then reuse them the next day. So it means that they've been able to minimise the battery size, minimise the engine size to suit the application, and importantly, those things are running for like 1,000 hours a year in terms of engine hours, compared to a recreational craft, which is like 50. That's a classic example of why one size doesn't fit all, because they've got a dynamic and they've designed something for a particular scenario. What we've looked at is that use case that I put forward to you before in terms of the average hours. And what that shows is that when you actually look at boats compared to cars, so much of the carbon is actually in the supply chain and manufacturing. In fact, for most of them, and they vary by boat types, but usually about 50% of the carbon in the life of a recreational boat is actually in the supply chain and the manufacturing process. And that's, I guess, it doesn't come as a great surprise insofar as that the operating hours are so low. But the reality is, compared to a car, cars have got most of their carbon in their operating phase of their life. And the reason for that is that what most cars are doing at this point in time is very different to what most boats are doing. And I think that we just need to recognise, and this is a really important point, because often policymakers think, well, it applies to automotive, it should apply to recreational marine. Boats are much more like aeroplanes than they are cars. And the reason being is it takes 10 times the energy to move a boat through a water than it does a car across the ground. And like planes, boats are all thrust. If you want to move, you need thrust. And so the reality is that our behaviours and the way that the craft behave and what their life cycle assessments are more a reflection of that. And so they're a lot heavier, the power requirements are a lot higher, and they travel a lot less, and they use a lot less hours. So all of those parts, when you bring them together, very much change the equation, particularly in LCA analysis. So if we look at, and I've taken a sample of the examples that come out just to show you how they've fallen relatively, just on the simple baseline position. So if we look at a displacement motor yacht, it's got average hours of 48, it's got a life of 45 years, and the yellow one is a baseline. So these are relative amounts of carbon through the life of the craft, depending on different propulsion systems. So if you look at the hybrid one, it's got slightly more carbon. And that's because there's just more components in the propulsion system, because you've got to have two parts to it fundamentally. You do get some savings out of some elements of it, but again, the manufacturing process and the embodiment of carbon within that are part of the equation. One of the difficulties, if you look at the electric side of the equation for the displacement motorboat, and just remember, this craft has less than 20% of the range of its liquid fuel counterpart, which doesn't, particularly for a displacement motor yacht, probably is a significant impairment in actually its purpose. But for the purposes of this model, the reason that you've got such a high outcome from it is there's so much carbon in the actual manufacturing process, particularly of the batteries, and also the replacement of the batteries in multiple times over the life of the craft, based on current technology, and that's the sort of reality of it. And so because when we got a lot of these figures back, they were quite surprising to us. And so part of that equation is we obviously drill back into the engineers and say, could you explain to us where that has manifested itself in this process? But you can see in that particular case that it's 180% more carbon in an electric alternative for a displacement motorboat that's got only 20% of the performance of its liquid fuel alternative compared to the baseline position. So it's a significant difference. And then the drop-in fuel, a sustainable fuel. So let me just pause to explain what that actually is, because it obviously comes up a fair bit in this study. So a drop-in fuel is an engineered synthetic fuel made from non-fossil fuels that can either be in a diesel form or a gasoline form, that is made through a range of different processes. But if you look at the diesel alternative, the sustainable diesel alternative, that might be made from waste cooking oil, it might be made from agricultural feedstocks, it may be made from specially forms of agriculture that are done specifically for it. And then it's made, using that as the carbon base. Often they might use hydrogen that's generated from green hydrogen that's created to actually blend with it to go through a refinery process to create these certain outcomes. And we'll talk a fair bit about that. But the term drop-in fuel fundamentally means that fuel can be used as a straight replacement for its fossil alternative, without any change to the engine systems of the vessels themselves. And so that drop-in fuel in this particular case shows a 40% reduction, and then the hydrogen one again being used both as alternatives as fuel cells or combustion, again it has still got a higher carbon footprint, mainly because again of the supply chain elements of the the supply chain elements of actually putting it together. So as we roll through the different craft, this one I thought was a great surprise, because I thought in relation to sailing yachts that we would see a significant improvement for electric alternatives. But the reality of this one, when we interrogated the data, it's because the engine hours on average were so low that, again, the embodied carbon within the manufacturing processes was such that the carbon footprint of the components and the replacement of the batteries during the life of the craft ended up delivering a higher carbon footprint than the alternative. So again, we can see where they fall with the hybrid components and the electric and the hydrogen, with again the drop-in fuel alternative being the one that actually competes more favourably with the current scenario. Going through, so high performance motor yacht, this is a planing, large 19-metre craft. Again, just so that you're aware, in this particular case, the energy storage on board would only provide for 10% of the range of the alternative, just from a physical aspect of actually being able to fit the batteries and hydrogen tanks actually onto the vessel itself. But again, I guess this is the one where you've got, because of its life, because of even when the engine utilisation hours are up around the 130 odd, it was still showing the significant conclusion that the drop in fuel was the alternative that was actually going to lead the best outcome for the decarbonisation of that craft. So the next one we actually did was looking at a higher scenario on a PWC. So again, just to understand what this means, this is a scenario where the battery on board the craft itself is orientated towards giving it 1 or 2 hours of run time so that it would then come back, be able to be charged, and the hire could go out on alternative craft or something like that. And it was run with 156 hours to see what the difference was. And this was in a scenario where the electric alternative really stood out as a solution because you could maintain a much smaller battery and configuration and things like that. So to put it in context, we actually went back to some of the other models to get some sensitivity across what is the relationship between the annual operating hours and the conclusions that were saying the drop in fuel was the preferred outcome. And they were quite significant. And if I take a step back, just remembering that the purpose of the study was to say, how do we decarbonise the industry as a whole, more broadly? How do we get the majority of users to basically move to a decarbonisation pattern? We have to use the average engine hours as the framework, because the standard deviation from those is where the bulk of the industry is. But the sensitivity was that you needed to get operating hours between 400 and 700% higher before the electric alternative started to become competitive, even recognising that the range and performance was significantly down. Now, that's all based on current and forecast technologies, and I think the important thing is it's not like we're looking backwards and saying, well, that's yesterday's technology, therefore the report's out of date. What Ricardo did was to actually take a projection based on the best intelligence we have today on what the performance will be in 2035. So they had to take a forward-looking view so that the report itself was saying, how do we actually have a forward strategy on it? What do we think the increased performance and life of batteries, as an example, will be? What do we think the availability of hydrogen will be as we move through those processes? And more importantly, what do we think the grid mix will be of electrical supply based on the current plans for sustainable electricity across mature markets in the world? So they've had to factor all of those equations into this to come up with these conclusions. But the reality of it is that across those different types, it's pretty obvious that the standout solution for decarbonisation of new craft coming through based on that model is really based on sustainable fuels. And I think what's really interesting about that is that as I said, this deals with the majority of the market based on the way people currently use boats. And there are plenty of use cases like the Go Boat and various other ones that operate outside that space that can make their particular scenario work. There's also some really interesting opportunities that we'll talk about a bit later in terms of you can reduce the carbon in your supply chain and change the equation if you've got the ability to be able to source materials locally, you're able to source your electricity in a sustainable way from cradle to grave. And I think that there's opportunities for manufacturers to be able to prove that they've got a very low carbon product in the way that it's manufactured. So you can see this gives us a sort of baseline position. You can see the relativity of different elements and things like that. The black line being the sustainable fuels. So when we move to effectively looking at some of the key parameters, I guess one thing that we can't forget about in all of this is actually the existing fleet. And probably, you know, there's 30-odd million boats around the world. And if I use the US figures, and the reason I use them is that they're probably the most robust data set that we can access, just to give an indication. So there's about 12.5 million boats in the US. They sell about 250,000 new boats a year. Interestingly enough, about 50,000 of those are PWCs. But if you look at that, you know, the reality is that the medium expected remaining life of the existing fleet is more than 20 years. So if you've got the majority of the boats that are out there and you're doing a replacement rate of 250,000 on 12.5 million, the rate at which you'll actually replace the existing fleet over the next 20 to 30 years is very slow. So if we're trying to hit headlines to actually decarbonise the existing fleet, we actually need a solution for the existing fleet. In fact, there's enormous value in the existing fleet because all the carbon that was used to manufacture them has been spent. It's already in the atmosphere. So there's a lot of value in actually utilising those craft and keeping them going for as long as possible. And so obviously the easiest way to actually decarbonise the existing fleet is also with sustainable fuels. And so I think that the key that we see here is that, the other component is that we've seen trends changing in terms of the way people access boating. And so historically, baby boomer generation, which was the foundation, I guess, of recreational boating really in terms of the market space, had a sequence of buying a smaller boat, then a larger boat, a larger boat, a larger boat. Younger people today, if we look at the sort of Gen Zs and Gen Alpha emerging, they're very much orientated towards, I don't want to own it, I just want to rent it, I want to borrow it, I want to do something like that, or syndicate it, or subscribe to it. And so we are seeing the rise of things like rental, like Go Boat, or boat clubs like Freedom Boat Club, or boat syndications of ownership and things like that. And what's interesting about those is that obviously if you've got multiple owners, 10, 20 or whatever it is per boat that are getting access to various things, then you're dividing the carbon by the number of users. So there is actually a carbon reduction strategy associated with the utilisation of that. It also changes the equation in relation to the number of engine hours that are used, because obviously those club boats and syndicate boats like the Go Boat ones are not used for 50 hours a year, they might be used for 500 hours a year. And if people can then accept that there's going to be a change in, I don't need to have 1,500 litres of fuel on board, I can get away with the equivalent of 200 litres because I only ever go boating for 3 hours a day, or I'm in a club and I can't use the boat overnight and I can't take it outside this particular area, then we will see changes in the way that people interact and the products and definition of what people require. But like all things, that's just a particular scenario and use case and part of the market. And so the reality is still the bulk of the market still sits where it sits. And if we're looking to decarbonise it, we've got to have a strategy. So ultimately, coming back to that, there's no one size fits all. And the conclusion that sustainable fuels are the best way to decarbonise the recreational marine industry isn't to say that that's good and everything else is bad. Far from it. In fact, we need solutions to actually deal with all of the use case. We need changing behaviours that deal with the use case. We need investment in battery technologies and electrical propulsion and various other things to lead us to a whole range of different solutions that actually solve all those problems. But the reality is right now is that sustainable fuels, are actually the pathway that will get us to being, for our industry, to be able to actually meet the requirements of the Paris Agreement. And I think one of the things that's really important about that, and there's a whole range of things that are going to change about global standards, whether there's safety standards associated with electric propulsion and charging, whether they're fuel standards for sustainable fuels so that engine manufacturers will actually warrant the engines for the use of those fuels and the standards are all set and the supply chain elements are set. I think that those are the key elements that we're going to have to work through from a policy setting point of view. But I just wanted to give you a little bit of background on a couple of things that are important, and that is that if you look at the Australian electrical grid and how it's changing over time, and this is the really thing, when we did this work to find out how much carbon was in the history of, in the supply chain, so much of it is where do you get your electricity from in the factory that makes the widget that goes into the component that builds the engine. And so when we looked at this, I just thought I'd give you this sort of little assessment so you can see that Australia is on a pathway to using more renewables. It's really interesting to have a look on a state-by-state basis as to where various things are, because there are certain advantages in certain states in Australia where there's a high level of renewables, like Tasmania, for instance, with their hydro and stuff like that, that already exist. But you would have seen that notwithstanding the fact that we're doing well, The reality is to actually address the issues to actually decarbonise the broader industry isn't quite on track. And I think that's part of the challenge that we've got. So our advocacy, in addition to the work that we're doing here, is I think as a community, we should be really insisting that policymakers actually use this LCA approach to actually evaluate, even the electricity supply components of it. So, if you're going to build an offshore wind farm, I'd really like to see the LCA analysis of that to make sure it is actually going to deliver the proper carbon reduction that's being promised, because from the studies that I've seen, it may not. And I think as a community, that's really important, that we need to understand how our systems are actually delivering genuine carbon reductions. If we're going to do all the hard work that we have to do to meet our obligations, I think we have the right as a community to demand others to do the same. And so it's just a point to make that there are issues, but if we look at sustainable fuels, because the obvious question that comes back when we say, okay, sustainable fuels, that's the answer, you're going to go, great, where am I going to get my sustainable fuels from? What is the supply chain going to be for that? So, and what are they? Do they exist and all those sorts of things? So it's interesting, in the US, there is a whole range there are actually pumps on marinas today that are actually selling sustainable fuels. And that there are companies in the US at the moment that are actually manufacturing and delivering these types of products. We don't have that maturity in our market here, certainly, and this is part of the reason that we need to be able to communicate this report to policymakers and other ones, because we need support to actually build the supply chain for these sorts of things. And if you look at it and say, well, that's unlikely to happen, a good example of it is already happening. So CSIRO and Boeing have just launched in August a sustainable airline fuels roadmap. And they've worked out, how do we actually get these sustainable fuels in Australia? How do we deliver them? What are the volumes and quantities we need? Even what is the reality of the cost compared to the alternatives? And so you can see, you could just imagine the amount of fuel that airlines use that need access to that in Australia would far outweigh what recreational boats are. So I put down the bottom in the red line to represent the forecast volume of actual marine fuels that are currently used in Australia. And we need to do work to validate that data, but the ballpark is that it's about 300 million litres per year. So we need a supply chain to be able to deliver us about, and I say that that is a very much a ballpark figure because we don't have access to the hard data, so we've extrapolated it back from a whole range of different data sources, and it's sort of the number that meets in the middle. But the reality is of that scale. So if you compare it to the 10 billion litres that the airline industry currently uses, no one's going to go out there and say, well, great, here's a business opportunity. I'm going to create a marine fuels pathway for you and I'll deliver you 300 million litres in the next 3 weeks. We need to tap into these sorts of processes because the reality is they're just petrochemical elements. These are just, refinery outcomes. Airline fuel is like a kerosene type of fuel, and petrol is can be a derivative or an upscale, and likewise diesel and other things. They can be made from the same components. So we need to be working with governments to actually try and advocate for support for these types of outcomes so that we can actually have a pathway and a supply. But we also need to recognise that there are some challenges, and the airline industry certainly recognises it, because without scale, the cost is multiples. And so like that graph on the right-hand side shows, they're projecting what different sources of fuels are relative to a cost per litre. So we also need to be cognizant to know that there will be, as we're all experiencing with electricity today, that we've lived through a life of the benefit of being able to dig things out of the ground and convert them into energy. And if we don't dig them out of the ground and convert them into energy and try and do it other ways, it costs more. And so, having said that, and interestingly, if I go back, one of the things that's really interesting, if you look at the technology that's actually changed in our industry over time, with the fossil fuel side of things, is we've actually reduced 90% of the engine emissions since 2010, and fuel efficiency in engines actually gone up 40%. So I said this study doesn't cover the carbon of different hull types. In fact, we adopted the same carbon footprint of all of the different hull types for each option because it's the same craft just being propelled by a different technology. But the reality is that, increases in hull efficiency, the opportunities for foiling for faster craft and various other things will actually significantly reduce the energy required to move the craft through the water. And that's part of the way that we'll be able to address some of the increased costs associated with the energy that's going to be required to move them through the water. And so ultimately, I guess the way that we see this process moving forward, given that that broad conclusion is that sustainable fuels are actually the way to actually decarbonise our industry, is the first thing is to, we got this report, we launched it 11 days ago in Amsterdam at METS. It's now out there in the industry. We're engaging with policymakers all over the world. We're engaging with industry all over the world, and we're looking for questions and feedback from industry to be able to inform what we need to do to go forward with the next steps and where those questions and information are. The second one is really to actually work to create a decarbonisation pathway. And part of that will be to work very closely with government in actually building a task force to actually work this through, identify what the issues are. So in its most simplest form, if we were able to do a study today that said this is actually how much marine fuel we use across the whole sector, and this is where we use it. So if we had that intelligence today, which we don't, if we had that, then all we have to do is figure out what are the sustainable fuel pathways, how are we going to get it, and how do you marry the two together. Sounds easy. Obviously, it's very much not easy, but the reality is that that's part of what we need to do, because what's interesting about that is that it's an easy statement to make, but if we actually do it, then our industry has far exceeded the requirements to meet the requirements of the Paris Agreement. We're done. That's how we do it. And we know that that's how we do it. And so I think that's a really important message that we actually need to get through. But we can't do it by ourselves. We have to do it in collaboration with government and policymakers to actually set that pathway. The other one is really just to look at two other parts, and that is how do we empower our industry to start informing themselves about the decisions they're making in manufacturing, as an example. And part of that is we're looking to actually create an LCA, so an LCA toolkit, effectively an online tool that manufacturers can use to actually assess different material sources and various other elements to actually understand the carbon implications of the decisions that are made, and to provide for opportunities for suppliers of materials to be able to provide information about the carbon footprint of the pathway of their materials to build up that full LCA. In other words, provide that information. And so that's an exercise that we're currently working at. What we want to do is to create a global set, because one of the challenges we all have, of course, is that materials that go into anything that we build come from a supply chain that's truly global. And so we need to basically look at it, particularly when we're talking about propulsion systems, because most of the propulsion systems, of course, are being imported. And so we need to actually understand how all of that goes together and provide those toolkits. The other one is to see whether we can create an online system that's a very simplistic one for consumers. So consumers can start to make a decision about using little sliders and various other things that when they're considering what sort of craft they want, what sort of use that they want, how do they use their boat, what's their intention and things like that, they can get some feedback as to say, well, no, in your particular case, if you're only going to be doing that, this is the best thing for you. Or if you're going to be doing that, this is the best thing for you. And I think part of it is the empowerment and education. And again, this has to be an entirely collaborative approach to work our way through. This is why this sort of actually broader conclusion that there's no one size fits all is actually the reality across our entire economy, is that we actually have to have multiple streams. And that is, it makes a lot of sense that aircraft and marine, in a lot of senses, are using sustainable fuels. And those sustainable fuels can be drop-in liquid fuels, they can be hydrogen, they can be all those sorts of different things, and ammonias and various other things. But because the electrical grid will be very much focused on transport, terrestrial transport, so cars, trucks, trains, all of those sorts of things. And I think we're even going to struggle to get the grid to meet those requirements. And so I think from a government policy point of view, the important message we want to get out there is that there needs to be a focus on this approach as well, and that we need support to create these pathways to deliver these supply chains for these and solve these difficult problems. We don't have all the answers to the difficult problems, but we've done the analysis to actually really understand what the alternatives mean, which then gives us the basis to have really important conversations to actually solve those problems going forward. Okay, thank you very much for your attention. I know it's a lot to take in, but really greatly appreciate you all coming today to hear about it. Thank you.